Hello. So yesterday I missed completing logarithms. I will try to sum up what I missed yesterday. I did not discuss 7.6 from Algebra 2. Common logarithms. Common logarithms, as we said, is a log with a base 10. The log base 10 مثلا of x can be written directly as log x. If I don't see any base, this means it is 10, as we said today. Change of base formula was in this lesson. I will not solve much on this because I think it's easy. But the rule was log base an is equal to log base bn over log base ba. And an example is log base 311. It can be written as log base 1011, log base 103. مش لازم يكون 10. It can be 5, 5, 3, 3, 2, 2, whatever the number. But anyways, the questions were expressed this in terms of common logarithms. We can just write the answer as log 11 over log 3. And this is all what was mostly displayed in this lesson, change of base formula. Okay, in lesson 3.2 in the pre-calculus, we have basic properties of logarithms, which I reviewed with you before, but just let's review them quickly. If I have log base b1, if this is 1, the answer will always have to equal to 0. For example, log base 5, 5 to the power of what is equal to 1? The answer has to be 0. If you reached here log base bb, b to the power of 1 is equal to b. For example, whenever I have log base 2, 2, the answer is 1. Log base 5, 5, the answer is 1. Okay, if you have log base b to the power of x, I can just drop the x over here and I will have log base bb. And this one is equal to 1. So the answer is x. For example, if I have log base 2 to the power of 3, the answer is 3. And here, if I have b to the power of log base bx, and this is equal to this, the answer is x. And these two are called inverse, I think, inverses. So here, if I have, for example, 5 log base 5 of 3, and you can try with the calculator, the answer will equal to 3. If this is equal to this, the answer is this. We have the same properties almost, but basic properties of natural logarithms. What's a natural logarithm? Natural logarithm is a len, and a len is just a log, as we said, log with a base e. Okay, so len 1 is equal to 0. Again, whenever I have a log and this number is 1, the answer has to be 0. So as if I'm saying that it's log with a base e of 1, the answer has to be e to the power of 0 to equal to 1. Okay, but we don't write log with a base e, we write len. And here, len e is always equal to 1 because it's len e. They, the questions, the other properties which were log bb. So if I have log e, well, the answer has to be 1 because e to the power of 1 is equal to e. Now, if I have len e to the power of x, I can just drop the x over here, so it will be x len e. And we know that len e is equal to 1, so the answer is x. And if I have e to the power of len x, the answer is x. So if I have e to the power of len 5, for example, the answer will be 5. Okay, as if the e cancels the len. There is a rule for that, it's long, but anyways, consider they are inverses, e and len. So because this is exponential and this is logarithmic, so they cancel each other and your answer is whatever that's here beside the len. Okay, for applying on this lesson, I will apply from 3.2 in the pre-calculus, or before I start 3.2 in the pre-calculus, I want to go through questions from 7.7 in Algebra 2, because this is where we started introducing base e and natural logarithms. And here I will quickly tell you the graphs of len. How does the graph look like? Okay, I'm expecting len to be an logarithmic growth, right? Why logarithmic growth? Because e is 2.7, so it's more than 1. So I'm expecting that the graph of y equals len x is just like any logarithmic growth graph, and I explained it yesterday, right? So ln x would definitely look just like this, and this point will be 1 and 0 as we solved today. Okay, and if I wanted to graph y equals, I just want to show you that the inverses are always their graphs are reflected on the line y equals to x. So inverse of ln is y equals e to the power of x, and this is also an exponential growth, and the graph looks like supposedly like this. Okay, and this point is 1, is 0 and 1. Okay, how do I think the graph of y equals negative ln x looks like? Y equals negative ln x. This negative outside the function causes a reflection on the x-axis. So this is y equals ln x. If I reflected on the x-axis, what will happen? It will look like a logarithmic decay. This will come up and this will come down, and it will look like this. This is negative ln x. Okay, so here is also 1, 0, and over here, if that's very enough for now, and if I want the graph of y equals e to the power of negative x, type y equals e to the power of negative x, this is inside the function, so reflection on y-axis, and reflection on y-axis, what will happen? This will come here and this will go there, so the graph looks like this. Will intersect here at 0 and 1, just looks like exponential decay. Okay, so this looks like an exponential decay, and this negative ln x just looks like a logarithmic decay. Anyways, these are the basic graphs for solving in طبعا we can move them, translate them, and everything. Regarding solving for this lesson, for example, they said number 20, write an equivalent exponential or logarithmic function. Okay, when I have e, I will not use log, I will use len, because len loves e and e loves len. Okay, so this is exponential, I need to change it to logarithmic. How will I change it to logarithmic? My base is e, so len, I will not write len base e, okay? So len, and this, the power used to come outside, صح? And this 8 comes here. So len 8 equals to negative x. Len 8 equals to negative x. Question 21, for example, e to the power negative 5x equals 0.1. So it will be len this equals to the power. So len 0.1 equals to negative 5x. And I will stop here, nobody wants me to simplify or anything, okay? Question 22, it's len 0.25 equals to x. This is already in logarithmic, so I need to change it to exponential. You must see the hidden e over here that nobody will tell you about, and tell me that e to the power of x is equal to 0.25. And question 23, for example, len 5.4 equals to x. Again, the hidden small e, so e to the power of x is equal to 5.4. Write as a single logarithm all the properties that we said about product and quotient and the power rule can be applied. So question 28, this is len 125 minus 2 len 5, and they want me to write as a single logarithm. Okay, so the minus, I will change it to a division, and this I would take it as a power. So I can just write len 125 over 5 to the power of 2, or len 125 over 25. Sorry, there's no equal. Or len 5. So I wrote it as a single logarithm. Again, question 29. 3 len 10 plus 2 len 100. The plus, you can convert it into a multiplication and take the powers back to their places. So len 10 to the power of 3 times 100 to the power of 2. How many zeros now? I will have these are 3 and these are 4, so I have 7. It's kind of len 10 to the power of 7, or I can write it as 7 len 10. Okay, let's say question 33. 3 len, you can solve more from the book. This is page 505 in the pre-calculus book. So I can say len x, if I take the 3 here, it will be a multiplication with the 2. So len x to the power 6 times len خلاص 3 to the power of 4. Okay, and what's 3 to the power of 4? It's 81. So len 81 x to the power of 6. Here I've written it in one logarithm. So here questions, the coming questions, they want us to solve, but the questions now include exponential functions. For example, question number 34, I can have exponential equations or exponential inequalities. Okay, so for example, I have this question. I would go for 6e to the power of x equals to 35 plus 3, 38, and then e to the power of x equals to 38 over 6. And then how will I get the answer? I can get the answer by len both sides. Len both sides. If I len both sides, I will get len e to the power of x equals len, and this is 38 over 6, all of them in the len, because when I did len, they were already both here. Drop the x down, and len e is equal to 1. This is 1 equals to len. Again, when you use the calculator, you will have to put len open bracket 38 over 6 and try it. The answer is 18458. Okay, another question from these, or I will go to one of the inequalities. Question 41 is solve this one. How will I solve it? I will len and not log, preferably len both sides. So I'll drop the x in one step. It will be x len e less than or equal to len 8.7. Okay, I will start solving from lesson 3.3 in the pre-calculus book, properties of logarithms. I explained yesterday the properties of logarithms. I want to solve from this book because it has all the len and all that. 185, page 185. The first questions are asking us to express each logarithm in terms of len 2 and len 5. For example, question 1, len 4 over 5. I'm thinking of changing the division into a subtraction. And then I'm thinking of changing this to 2 to the power of 2 minus len 5. And then I'm thinking of dropping this here to 2 len 2 minus len 5. And here I expressed it in terms of 2 and 5. Okay? Another one, or I will go to express in terms of len 3 and len 7. Express in terms of len 3 and len 7. For example, question number 9, len 63. Okay, I can change 63 to 9 by 7. So len 9 by 7. And if I have it a multiplication, I can change it to an addition. Len 9 plus len 7. And this 9, I'm thinking of keeping it as 3 to the power of 2 plus len 7. I will drop the 2 here, so 2 len 3 plus len 7. And here I expressed in terms of len 3 and len 7. Okay? Okay, regarding expanding and condensing, and condensing, okay? For did we solve from these questions exponential and logarithmic? Okay, we did yesterday, I think, expanding and condensing from here. So lesson 3.4, exponential and logarithmic equations. Okay, and I will solve from page, I know you have a problem with solving and when to len and when to log and when to change to exponential and all of that, and I remember the problems and what was confusing you in page 197 in the pre-calculus book. Okay, in the pre-calculus, the first questions were asking us to solve each equation. So this is the most important part that used to confuse you. Solve each equation. For example, number 1, 4 to the power of x plus 7. I don't think the very long ones would come in your test because of the time. So for this question, I cannot make the bases the way we did in the other videos. I cannot make the bases equal, but I can go for log both sides because I don't have any logs at all. So if I say log 4x plus 7 is equal to log 8x plus 3, and then I would drop these. I could have done this in the same step. I would say x plus 7 log 4 equals x plus 3 log 8. Okay, what should I do next? I think, yeah, this is the very long one, and I will have to start distributing, and I don't think this can be in your test, but anyways, x log 4 plus 7 log 4 equals x log 8 plus 3 log 8. And then I need to put the x's in one side and the numbers in the other side. So x log 4 minus x log 8 equals negative 7 log 4 plus 3 log 8. And then take x as a common factor. Log 4 minus log 8 equals negative 7 log 4 plus 3 log 8. And then isolate x. X will equal to negative 7 log 4 plus 3 log 8 all over log 4 minus log 8. And this would give me an answer. Let me just calculate it. Log 4 plus 3 log 8 over log 4 minus log 8. And this would give me an answer as 5. And you can check, substitute the 5 here and the 5 there. And if you had it in MCQs, you could have tried the 5 quickly, but the numbers are large, I think so. Okay, for question, let me take, for example, question number 2. Okay, question number 2. It's 8 to the power of x plus 4 equals 32 to the power of 3x. I think I can make 2 to the power of 5 and 2 to the power of 3, right? So no need for logs here. It's 2 to the power of 3x plus 4 equals 2 to the power of 5. And here 3x plus 12 equals 15x. 12x equals to 12 and x equals to 1. We've solved like these questions before. Okay, solve each logarithmic equation. Solve each logarithmic equation, and here I'm gonna pick the ones that have len. So len a equals to 4. What shall I do to solve over here? And I have log in one side and there's no log in the other side. You have to change to exponential and think that there's an e over here. So e to the power 4 is equal to a, and then this is a calculator job. For number 11, the answer is 54.60. If you have no calculator, you would stop at e to the power of 4. For question number, let's say 13, len negative 2 equals to c. For this question number 13, there's no real solution because a log cannot be negative. This number can never be negative. For question number 15, let's say 14 plus 20 len 7x is equal to 54. I would isolate the len I will isolate the len. I will send the 14 to the other side. So 20 len 7x equals to 54 minus 14, which is 40. And then len 7x is equal to 40 divided by 20, which is 2. And then I will go to exponential, being e to the power of 2 is equal to 7x, and then x is equal to e to the power of 2 divided by 7, and then the calculator would give you an answer approximately 1.06. If you have the choices, maybe this would be the choice because you are not allowed to use the calculator. Question, let's say, okay. Let me say 28, for example. Again, solve each equation. 6, for example, 28, 6 to the power of x equals 28. What would you do over here? You would log both sides, and then I'll drop the x in one step. X log 6 equals log 28. So x equals log 28 divided by log 6, and then on the calculator your answer will be 1.86. Another question, for example, 31, e to the power of 3x plus 1 equals 51. I will len both sides, okay? So here I'll drop 3x plus 1, len e equals len 51. Len e is 1. So x is equal to len 51 minus 1 divided by 3. And make sure this minus 1 is not in the len. It's not len 50, it's len 51 minus 1 divided by 3 in this order. And the answer for this question is 0.98. Another one, for example, let's say solve each. Okay, there is another pack, solve each equation. Question 39. I have 7 to the power of 2x plus, I think this is the very long one. I don't want to do the long ones because I don't think this is going to be there. Question 50. I commend these. Okay, anyways, let's say question number 50. Okay, question number 50. E to the power of 2x plus 3e to the power of x minus 130 equals to 0. Okay, I think factoring is fine here because this is 2x and this is x, so I can split this to e to the power of x and e to the power of x. If I multiply them, it would be x plus x, e to the power of 2x. And what will I do to the 130? I'm thinking of two numbers, their difference or their sum is 3. Let me try 130 divided by 13. 13 and 10 is obviously good, and I would keep the bigger one as positive and the smaller one as minus. So here e to the power of x is equal to negative 13, or e to the power of x is equal to 10. This would give me, if I len both sides, I would get x len e equals len negative 13, and this is impossible. Here I would get x len e equals to 10, or as we said, it's this len e is 1, so x is equal to 10, and x equals to 10 is the answer in this case. Okay, let me solve another pack which has len, like over here I have len x plus len x plus 2 equals to len 63. Again, as we did with logarithms, len is also a logarithm. So len x times x plus 2 equals len 63. So x squared plus 2x minus 63 equals to 0. I cancel the len together. And then I can factor, maybe for question here I have x and x. Maybe 63, 9 and 7, and the bigger one should be positive, the smaller one should be negative. Either x equals negative 9 or x equals to 7. This is impossible because I cannot put a negative 9 over here nor a negative 9 over here. So your answer is x equals to 7. This is the only possible answer. Let's say okay, like question 73. for example, log, okay, here it's a common logarithm because they didn't write any bases. Log 2x. What will you do over here to this one? Okay, I cannot ignore, it doesn't have a log. So let me take the logs in one side. I keep the number in the other side to make it clear for you. Minus log 2x equals to 1. Okay, this one doesn't have a log. I cannot include it anywhere. It's on one side and all the logs on the other side. This is a minus, so I can change the question to log 3x plus 2 divided by 2x equals to 1. And now that I have a log in one side and a number in the other side, I would change to exponential. And this base is 10, so I can say 10 to the power of 1 is equal to 3x plus 2 over 2x. And then I can multiply here, so 20x is equal to 3x plus 2. And then I can say 17x is equal to 2, so x is equal to 2 over 17, which is approximately equal to 0.12. So because you used to make this mistake, do not ignore the one. Do not consider the one that it has a log. It doesn't have a log. Okay, I'll show you one more of those and I'm done. Like question 73, for example, log base 9x minus 2 equals negative log base 9x. Okay, again, I will send the number away and bring those together. Log base 9x plus log base 9x equals to 2. These are log base 9x squared, because I multiplied 9x with x, equals to 2. And then I go to exponential, so 9 squared equals 9x squared. So 81 equals 9x squared. So x squared equals to 9. So x is equal to 3, and I will not take the negative 3 because I cannot put negative 3 here nor there, and it's not allowed. So only x is equal to 3. I tried to cover, and you try to solve more. I tried to cover as much as possible from logs questions, and you can solve more from your book. Thank you.